Hi, Greg Smith from SMA America Solar Academy, and today I'm going to talk about ground fault detection on our transformerless inverters. Now, all of our inverters have a way of detecting ground faults, but today I'm going to focus primarily on how the transformerless inverter detects and reacts to a ground fault. Now, everybody's familiar with the Sonny Boy method of detecting a ground fault in accordance with 690.5. So the inverter has to detect the ground fault, interrupt the ground fault, and then inform the person that there was a ground fault. And both types of inverters do that, but the way that the transformerless detects a ground fault is much safer. But let's go and compare the Sonny Boy 3, 4, 5, 6, 7, and 8000 US series inverters with respect to how they detect and react to ground faults. All right, so here's a Sonny Boy 7000. And we see the ground fault detection fuses here, one on the right, one on the left. This one just so happens to be configured for a negatively grounded array. So we have the 1 amp fuse here. So when the inverter connects to the grid, if there's a ground fault, it will blow this fuse. We'll also see a reading in the LCD indicating a GFDI fuse open, and then we'll also see the red light turn on. Now, let's see how the transformerless inverter reacts to a ground fault on the PV array. All right, so now let's take a look at how the transformerless inverter series detect and react to a ground fault. Now, the TL inverters look for ground faults before they connect to the PV array, and then constantly looking for ground faults after they connect to the PV array. But there's two different circuits for that. So the first circuit is called RISO, or isolation resistance, and that circuit is right here. So the RISO circuit detects ground faults before the inverter connects to the grid. So he doesn't act as a load on the array. He doesn't get the current flowing in the conductors that have been chewed on by mice or squirrels or whatever. So we never get the arcing and sparking from that. So instead what he does is he checks positive to ground and negative to ground resistance. And if it's above a certain value, then he determines that it is a safe array. Then he connects, starts making power. Now, after he connects to the array, he uses a different circuit to look for ground faults, and that's called the RCMU, Residual Current Monitoring Unit, and that's found right here. This circuit is constantly looking for ground faults, not only on the DC side, but also on the AC side. So the two circuits, one before connection and the other one after connection, make for a very safe and reliable ground fault detection method that does meet NEC standards. It's been thoroughly tested by UL, and this is the very first UL listed transformerless inverter in the United States. So the Sonny Boy transformerless inverters must operate with ungrounded PV arrays in accordance with 690.35, and we do comply with that. And because we operate with these ungrounded arrays, we need all this extra protection. But that's a different seminar. But what I'm going to do is show you how it reacts to a ground fault. So I'm going to turn the DC disconnect on, and then we're going to look at the LCD and the LEDs, because it's going to have a blink code just like the other Sonny Boys will. And we're going to see how it reacts. So I'm going to turn the DC disconnect on now. And it has a little bit different startup routine than its cousin over there. But we'll look at the display, and we'll see some very similar messages. And then we'll look at the LEDs, and we'll see what happens. So right now he's going through, he's checking the array for ground faults, along with some other things internally. And it won't take very long. And remember, he does not connect to the array to find this ground fault. He's just connecting between positive and ground and negative and ground. So there he tried to connect. You heard some relays trip, and we have disturbance, RISO, RISO. The red light is on, signifying that it is a ground fault, and there's also a yellow blinking light that gives the blink code error for this particular error code, and that's in the back of the installation manual. Now at this point, the installer would have to troubleshoot the array, find that ground fault, fix the ground fault, and then come back and just perform the regular commissioning procedure for the transformerless inverter. And that's how this inverter detects and reacts to ground faults. It's pretty simple. But if you want to learn more, you can attend one of our trainings. Just go to our website, sma-america.com, click on the Solar Academy tab, and then find a location that you would like to visit us. Thank you again for dropping by. My name is Greg Smith. We'll see you next time.